Satellites are always circling the globe, collecting data and making our lives easier. They help us get around, bring us entertainment, and now they're helping us make farming more sustainable, streamlining how we work toward cleaner waters, more productive lands, and improving soils that store more carbon. Introducing OpTIS, the Operational Tillage Information System. OpTIS uses publicly available satellite imagery to create an annual snapshot of how croplands are managed for soil health. This information is valuable to the agriculture industry to build a healthy, productive, and sustainable future for our farmers and communities. Users can access data on tillage and cover crop practices at the state and watershed levels. OpTIS data can help scientists, farm advisors, agricultural suppliers, policymakers, conservationists, administrators of carbon markets, and others. It gives us a clearer picture of where the most progress is being made to improve soil health and water quality, and where we need to focus resources and funding in the future. OpTIS is a powerful tool to help the entire industry move forward faster and in a more informed way. Technology has been a huge driver of progress in the agricultural industry. OpTIS is the next step toward building a more sustainable future for us all.
All right. Hello, everyone. Welcome to today's webinar on the Operational Tillage Information System Visualization Tool, or the OpTIS Visualization Tool. My name is Valerie Lung. I'm a program specialist for the North America Agriculture Program at the Nature Conservancy, and I'll be helping out with logistics today for our webinar. Just a couple of housekeeping tips up front. This webinar will be recorded and we will post it later to the CTIC and Nature Conservancy websites. As you might have already noticed, you've been muted on entry. We thought because of the amount of participants today, we would cut down on the background noise and keep you all muted, but we do want to hear from you. So there's a Q&A feature. If you hover your mouse over the bottom of your screen, you'll see a Q&A button. If you click on that, you can type your questions into the chat box. For those of you who are monitoring those questions and you happen to see one that you are also thinking of, you can actually vote on those questions by clicking the little thumbs up button. And that'll prioritize questions so that we get to those faster that participants have a lot of interest in. So what to expect today? We're going to have some introductory remarks from the OpTIS team. Then we'll go over the technology. How does it work? What do the results tell us? And who's using the data? Then we'll have a quick demonstration of the OpTIS data visualization tool. And we'll wrap up with some Q&A from you all. At the end, the presenters also have a quick poll that they would like you to complete, so don't pop off too quick. And I think that's everything for housekeeping, so I will turn it over to Shamitha, who will introduce herself and the other panelists.
Thanks, Valerie, and thank you all for joining us. I'm Shamitha Kirti, an agriculture and water quality scientist with the Nature Conservancy. And on behalf of all my colleagues at TMC, Dagan, and the Conservation Technology and Information Center, welcome to this webinar. We're so excited to talk about OpTIS today with you. So OpTIS is a new technology that uses remotely sensed data to monitor trends in the adoption of soil health practices. As you're all probably aware, healthy soil is the cornerstone of a resilient and stable farming operation. And it's, of course, our farmers' foremost capital asset. So wide-scale adoption of soil health practices like winter cover crops and reduced tillage can help to improve crop productivity, protect water quality, while also addressing the impacts of climate change by sequestering carbon and reducing greenhouse gas emissions. Healthy soils also ensure resiliency against floods and droughts. OpTIS provides us with a low-cost, efficient, and scalable way to monitor the uptake of these practices, and gives us valuable information to better focus our resources, tools, and research for a more sustainable agriculture system. Dagan, CTIC, and the Nature Conservancy have collaboratively spearheaded the development, testing, and application of OpTIS. Our project team includes Bill Salas, co-founder and CEO, Steve Hagan, co-founder and COO of Dagan, who developed the OpTIS technology. From CTIC, we have Mike Comp, Executive Director, and Dave Gustafson, Project Director. And from TNC, we have with us today Pipa Elias, Director of the North America Agriculture Program, Eugene Jacobson, who's GIS Information Manager, and myself. We also have a communications team of Christine Griffiths from TNC and Steve Oblo of CTIC online today. Several foundations and corporations have provided generous support to make our work with OpTIS possible, including the Walton Family Foundation, which supported the development of a new visualization tool that we will demo later this hour. Thank you again, and over to Steve Hagan, who will tell us more about the OpTIS methodology.
Thanks so much, Shamitha. And thanks to everyone out there for joining us today to learn more about OpTIS, these data and insights they can provide. Shamitha said, my name is Steve Hagan. I'm a senior remote sensing scientist at Dagan, and I'm gonna take you for a brief walk through the technology that produces these data. So if we could go to the next slide. OpTIS, as Val and Shamitha said, stands for the Operational Tillage Information System, but it's actually more than tillage practices. The system generates information on cover crops and crop rotations in addition to information on tillage practices. The system uses publicly available remote sensing data to map and monitor the adoption of tillage practices, cover crops, and crop rotations. The raw tillage practice cover crop information is from OpTIS is at the subfield scale, and it's mapped across the Corn Belt. These data also go back through time. So in this application, we generated data from 2005 annually up to 2018, again at the field scale, making these data longitudinal. And that is, we track and model each of the about 1.7 million farm fields through time, looking at changes in management practices, including crop rotations, tillage intensity, and cover cropping. So the information is processed at the field scale, but summarized and distributed at aggregated scales for public insights. The Huck 8 watershed data and the ag district data, state level data, those are the level of distribution through CTIC, and that way we ensure that grower privacy is respected. These summarized data, as you can see at the bottom of this slide, are available freely at CTIC's website. Next slide, please, Val. So OpTIS technology has evolved substantially in the decade since about 2010, 2011, when we received grants from the USDA Small Business Innovation Research Program and NASA's Applied Sciences Program to start research. So in that decade, 9 or 10 years, we at Dagan have worked to improve the methods and algorithms, going from what at the beginning were local demonstrations of a link between crop residue measured on a field and remote sensing measurements, up to a wide area deployment of this technology. And that allows us then to map the Corn Belt. So we rely on data from multiple satellite sensors, and we integrate that data across the entire season and across years to make estimates of residue cover, tillage practices, and cover crops. And on this slide, you can see here the concept for mapping cover crops. We track level of greenness. That's on the y-axis of that chart there. Over time, which is on the x-axis, at the farm field or pixel scale over seasons. And here we're looking at the fall of 2016, spring of 17, and summer of 2017. And we look for patterns in the green signal that indicate if the pixel was cover cropped, or if it had a commodity crop, or had no winter cover at all. Next slide, please, Val. So we compared our satellite-based estimates of information in two ways. We compared them to roadside observations at the farm field level, and we compared them at the county scale to ag census data that are summarized total acres of a particular practice at the county scale. So at the field scale, we collected in total more than 5,000 unique observations across time on about 1,000 fields in the Corn Belt. And we did this by creating a mobile app and partnering with certified crop advisors, crop consultants, and folks from the soil and water conservation districts. And we did that in about 30 regions. You can see that on the map there, 30 regions across the Corn Belt. And then we use those observations taken from the field to compare to our satellite-based observations from OpTIS. And we see strong relationships. The accuracy is typically above 85% for both tillage practices and cover crops, but maybe more meaningfully, the kappa statistic, Cohen's kappa statistic is usually 0.6, 0.7, and the kappa statistic accounts for an imbalance in the number of observations in the data categories and the associated probabilities that matches were made by chance. So in all, we validate well to the field level data, and we see similar sorts of relationships when we look at the county scale data from the ag census. And so that gives us some confidence moving forward. Next slide, please, Val. So with OpTIS, we can gain an understanding of the spatial patterns and the temporal patterns, the patterns through time, and we can answer questions like, how does the rate of adoption of these practices change over space and time? And we can get an idea of what baseline levels of adoption practices are, and we can compare against those as we move into the future, looking for improvements in regions through time. So, this type of remote sensing based information I think is valuable in and of itself, but we can combine the observations from OpTIS with powerful biogeochemical models to gain even deeper insights into outcomes associated with the management choices that growers are making. And that's where the DNDC biogeochemical model comes in. And that's what we used in this application across the Corn Belt. DNDC stands for denitrification decomposition. This model was developed in the 1990s by Dr. Chung-Shen Lee and researchers at the University of New Hampshire. And over those many decades, DNDC has been used in more than 500 peer-reviewed studies. So it's a process-based model that uses ag management information, such as that is produced by OpTIS, combines that with weather information and information on soils. That's input into the model. And then by modeling soil microbial processes, vegetation growth, by tracking carbon and nitrogen cycles, DNDC produces estimates of outcomes, soil organic carbon, greenhouse gas emissions, and reactive nitrogen and other attributes. So again, this modeling happens at the farm field level, and we track and model each of, again, about 1.7 million farm fields through time, looking at changes in management and then modeling the associated outcomes. And just a side note, an added advantage of the satellite-based approach to mapping the practices is that we can track important information on the field level from year to year. And information such as how many consecutive years was a particular field in no-till, the idea of continuous no-till. This type of information is important when it comes to soil health outcomes. And that's then captured here with the DNDC model. So again, run it on about 1.7 million fields with OpTIS management data as input. But more than that, we run a set of counterfactual scenarios. For example, what if this particular field had no use of conservation practices in the past? And we compare that counterfactual to the OpTIS observed model run, and we can compare outcomes of those two cases to get a better understanding of the soil health benefits associated with conservation practices. So the information, again, is processed at the field scale, but summarized and distributed at aggregate scales for public insights. Next slide, please. So what's up next? Well, we continue to work to improve the underlying technology at Dagan and the links between OpTIS and DNDC. We're bringing those two technologies closer together and having them interact in new ways. And we continue to work with our great partners at TNC, CTIC, Walton Family Foundation, other groups to make these data available to the public. And we're working to expand the application both spatially out to new areas in the Wheat Belt and in the Chesapeake, as well as temporally updating the products up through 2019, 2020, and beyond. And another key piece of the work in front of us is to get these data out into the hands of folks that can use and benefit from the data. And that's, you know, one major reason why we're having this conversation today. And we're looking to continue to build our partnerships with governments at the state and at the federal level. The state of Indiana has been a great partner throughout the history of OpTIS. USDA Office of Energy and Environment Policy has provided great feedback and support. And we're looking to expand these relationships and others and build new partnerships as we move on. So I think next is Dave Gustafson. From CTIC. He's going to walk you through the results. Over to you, Dave.
Thanks very much, Steve. And thanks for everything you folks there at Dagan have done to help deliver OpTIS. So I will be speaking briefly. Dave Gustafson, I serve as a project director here at CTIC. Had several years in industry before joining CTIC here a couple years ago. So next slide, please, Val. There are many possible applications of the OpTIS data set. As should be clear by now, we actually have literally more than 1 billion acre years of data that have been released in 2019 with the Corn Belt study. As Steve explained, we can use these data to measure soil health baselines and trends, but also use them as input to water quality models, in addition to the biogeochemical models that Steve explained. And this is something we're pursuing here at CTIC even now. We also obviously can use the data that have been released to help target conservation efforts at those parts of the Corn Belt and elsewhere in the country where perhaps we're not seeing the same level of adoption of things like cover crops that might be beneficial. Another potential use of the information here, and we have projects ongoing in this area, is to partner with others such as the Ecosystem Services Market Consortium, or ESMC, to help use such information to provide verification in a very cost-effective manner of practices that matter with respect to things like soil carbon and water quality impacts. And of course, there's no limit to the kinds of applications here that are possible with this, looking at biodiversity issues as well. So if you could go to the next slide, please. The main set of data that we have released so far here with OpTIS is a data set for the entire Corn Belt. And this came out in July of 2019. And we are releasing data concerning the adoption of various kinds of tillage, cover crops, and also winter covers such as perennial crops and winter wheat. And then we also have soil health metrics, and these are based on looking at multiple years of practices such as continuous no-till, and we can track that because of the nature of the data that are being collected via OpTIS, and Steve explained that very briefly. And then also, we're plugging the OpTIS estimates of the adoption of practices into the DNDC model, and then reporting back out through the website changes in soil organic carbon, nitrous oxide emissions, nitrate leaching, as well as changes in the soil moisture holding capacity. And this last feature is extremely important with regard to building resilience, resilience to drought, but also reducing the impact of floods downstream. So as you can see, there's many applications of this information. Next slide, please. This is a snapshot of what OpTIS is telling us things looked like in the year 2018 with respect to the adoption of conservation tillage on the left and the adoption of cover crops in the right. And again, we have this information going back to 2005, and I'll show some time series in a moment. But as should be clear right away, there are some interesting patterns to the adoption of both of these sets of conservation practices, and the OpTIS data allow you to explore this in greater detail. If you could go to the next slide, please. Here at CTIC, we were formed back in the early 1980s as a way to deliver the information that are on the left side of this chart, and that is the adoption of conservation tillage across the I states and in certain other areas of the United States. And what we've done here is to show how the CRM data, which stands for Conservation Residue Management Study data, that were collected using funding from USDA and released through CTIC up until 2004, and in the case of the I states, a little bit beyond. You could see that the CRM data on the adoption of conservation tillage match quite nicely with the data that we're collecting via OpTIS, and of course the OpTIS data then take us from 2005 up until the present time. And we see that there are some interesting slight differences here in the level of adoption of conservation tillage among the three I states, but that in general, we've kind of leveled off in I would say the 50% range in terms of the level of adoption of conservation tillage. And, but it could be true that things like the greater adoption of cover crops could help us go to even higher levels of adoption of conservation tillage practices. Next slide, please. Here, what we're doing is we're comparing the OpTIS data on the level of adoption of cover crops across the three I states to the information coming from the Ag Census. The Ag Census reported out the level of adoption of cover crops in both 2012 and 2017. And you can see here that the results that we're getting out of OpTIS are quite similar. And in fact, Indiana, and we'll be hearing from Jordan Seeger here in just a moment, has been a leader for quite some time in the adoption of cover crops. But we also see that both Illinois and Iowa are now, I would say, seeing increases in the level of adoption of cover crops as well. But that overall big picture, it is certainly true that these are still sort of in the single-digit percentage range in terms of adoption. We're getting a bit higher than that in Indiana, but we definitely still have a ways to go before we see broad-scale adoption of this practice, which is believed, and I think has been demonstrated to have numerous environmental benefits. So next slide, please. As noted earlier, we then plug the OpTIS data into the DNDC model, and we can then map out the changes to soil organic carbon over time. And you can see that there are, again, interesting patterns here where there's been quite an increase in soil organic carbon up in the sort of the northern part of the Corn Belt. And certainly more so than in the southern regions, and this is consistent with the higher levels of organic matter that we see in those areas as well. So next slide, please. What I'd like to transition to now is to let you hear from some of the folks who have been using the data, and we have a representative from government, one from academia and one from industry, and we're really thrilled to be able to welcome them here today. And Steve mentioned that the state of Indiana has been a longtime collaborator on the OpTIS project. In fact, there was a pilot project done in the state of Indiana and released back in 2016 that was highly instrumental in getting OpTIS off the ground. So with that, I'd like to turn first to Jordan Seeger from the Indiana State Department of Ag.
Thank you, David, and thanks to CTIC and the partners for supporting this technology and also releasing the results you're finding and continuing to improve on that over time. We were really excited to see that release that came out in July with data across the Corn Belt. As mentioned, our department, the Indiana State Department of Ag, has been fortunate to have worked with CTIC and the partners during development, and our field staff primarily using that app that Steve mentioned would help kind of go out in the field and teach the algorithms. And those field staff have some experience already, knowing what kind of tillage was in the field, knowing what kind of cover crop or if it existed, and could really kind of help through the learning process with some of the background of OpTIS. We've taken a philosophy that you don't know if you don't measure. And we think that's especially true for conservation trends for all the reasons that we understand, we've talked about, to gauge progress, see what's working, where it's working, maybe where it's not, and what we can do more to move the needle. And really a focus on outcomes as well. So it's not just about throwing cost share dollars out there or the latest, greatest government program. We want to see real results. And OpTIS allows us to see those outcomes, see those results over time. We as a conservation partnership in Indiana, kind of including the Saltwater Conservation Districts, the state, the feds, have engaged in a windshield survey, if you will, tillage transect, since 1990, actually, for tillage, and started looking at adding cover crops in 2011 to our windshield survey. All that information's online if there's curiosity there. But again, we started that effort in 1990, 2011 to identify where we're making progress and maybe where we need to ramp up some of our government supported efforts. And really the thing about OpTIS that we found is great is timing and scale. There's multiple observations that are being flown. It's not just somebody, a conservation employee, driving across the field, past the field, doing a windshield survey, but multiple observations, extremely important. And then the scale. That's really cool. You saw some of the maps earlier that really zoomed down on small watersheds. That's exciting. And the reason it's exciting kind of for us in the conservation business on the government side is we can see, engage smaller projects. So whether that's a grant funded project on a small watershed, having OpTIS now be able to hone in at that small scale, still protecting farmer privacy, of course, but it's really important to see kind of quick benefits of our work and the results. Going forward, I know some of the groups in TN Nature Conservancy very engaged in this effort, but I think probably even more potential for OpTIS within the food chain system as some of these large food companies scale up their sustainability efforts dramatically. I think OpTIS could really be a tool, again, to look at the results, look at the impacts of some of that work, and be able to, kind of tell some of these companies where their grain is coming from, how it's being grown, if it's within a conservation or soil health system. And lastly, I would add, new exciting going forward is what has been mentioned on the increased modeling components on greenhouse gases, water quality outcomes in particular. That's really cool. Those are brand new tools that we've never had within government to really at scale measure some of the impacts of the work that's hitting the ground and the great work that Indiana farmers and farmers across the country are doing. Thank you.
Well, that's fantastic, Jordan. And thanks again for all of your support of the pilot project and your presence here today. It really means a lot to all of us. So with that, we're going to turn to Professor Ben Gramick at the University of Illinois. Are you muted, Ben? We can't hear you, Ben.
How about now? Sorry.
Go for it.
All right. Mobile phone access. Okay, so let me just talk a little bit about what we've been working on. I'm involved in a project, the two principal people that I'm working with that have been working with the OpTIS data is our Bowen Chin. Dr. Bowen Chin is a postdoc here at the University of Illinois. And the other person involved in the project is Professor Sundo Yun at Mississippi State University. And right now we were in the midst of a project trying to evaluate on-farm benefits of conservation practice adoption. And this is work that we're doing right now for and with the Natural Resource Conservation Service, so for USDA. So this is sort of how we've come to start to look at some of these data in the process of lengthy waiting for some other data that we were supposed to be using. We said, oh my gosh, look at this new OpTIS data set. It sort of caught our eye. I'd been bumped into Mike Comp and stuff at a meeting, and so I inquired about the data, and this is what sort of how we sort of stumbled onto it. Basically, though, what we've done with the data in terms of kind of a first study, I guess, was to try and look at, with a particular interest in drought resilience and conservation tillage, try to use the data together with yield information, weather, and other things. So we basically have combined the OpTIS data together with USDA NASS yield data with weather information over the years and the states basically that you see on the map there, or the maps that we saw earlier for sort of the coverage of the data product. And I've tried to, or have estimated econometric models to look at yield determination and the influence of conservation tillage practices on yield. And in particular, our interest was asking the question, do we get some yield resilience or yield protection benefits? In particular, of interest was the 2012 drought year. So this was sort of the context in terms of what we looked at. I think if you got the slide in front of you, you can see one key finding there with respect to soybeans in particular. While we didn't find any negative effect on corn, we do see an actual statistically significant, and you see the point estimate, I think it's about six bushel per acre yield protection in soybeans under drought conditions, and that's based on PDSI across that Corn Belt region. Just the last thing I guess I would say about the data product is, sort of how did I come to stumble onto it, or why am I using it? One, I'm interested obviously in these issues, but the other big one is that I'm an economist. I'm not a remote sensing scientist, and I don't happen to be working with anybody that does sort of core remote sensing. And so for whether you're an academic researcher like me, or you're working in other settings, you obviously have to have data in order to be able to ask some of the research questions that you're interested in and look at things. And so what this afforded me, was the opportunity to say, okay, we've got a data product here that's that has this tillage information, which is not information that's obviously widely available unless you're working directly with remote sensing researchers and others that are doing this kind of work. So it kind of created an opportunity there to bring multiple pieces together, and talking with Dagan and with CTIC, that's sort of how this came to be.
Well, thanks very much, Ben. And I know that paper is expected to come out soon, and we certainly look forward to it. And thanks also for participating here today. I'd like to next turn to our last user of data that's going to speak today, and that's Mark Schmidt at John Deere.
Thanks, Dave. So yeah, again, this is Mark Schmidt. I'm the Associate Director of Stakeholder Relations and Stewardship at John Deere, but I'm also the board chair for CTIC, having taken over that role this past spring. And I've been involved with CTIC as the John Deere representative since about 2015. So it's been exciting to see OpTIS evolve during that time to where it is today. And I wanted to make some of my comments largely from the perspective of John Deere, but also somewhat with respect to the opportunity that I think CTIC can help enable or continue to enable as part of advancing OpTIS. And when I was thinking about what to say today, I often reflect back on the fact that for how long John Deere's been involved with CTIC, and largely we've been involved with the organization back to 1982 since its founding, and we were essentially involved for three different reasons that I think still apply today in terms of how OpTIS is also going to be used. And those three reasons were really around fostering practical approaches to conservation, developing and sharing information and data products but then maybe most importantly, also providing a forum for coordinating different stakeholder interests. And, you know, I'm excited about all of you joining today, partly for the opportunity to learn from all of you, not only for us to share where OpTIS can go and where it can be applied, but to understand from you all as well around where you see the application and potentially how it can be improved. And all of those things certainly fit with CTIC's values. If I look specifically at OpTIS and talk about how we're using it internally, it's really serving three different functions for us. One is building understanding of conservation information, and I think I will propose it's an exciting time for conservation in terms of being able to deliver on likely some common goals in agriculture centered around increasing productivity, but also doing so sustainably. And when I've looked at how conservation, tillage, cover crops, and other practices have evolved through discussions within Deere, that level of maturity in the discussion has grown, but also developed further because of tools like OpTIS that are allowing us to do things differently and to understand how we can interact with the data differently. So the first part is building that understanding, not just with the experts that deal with those things regularly, but also others that need to be involved in the organization that aren't necessarily involved today. The second part is analysis. We often get questions around how to apply different forms of information to strategy, but you often lack the tools in doing that. And OpTIS has given us a more digital way to do that, where we can look at data spatially, but also temporally. We've heard about different scales, regional and in field, on how that can be used. And that's been extremely valuable for us with the experts, but also those, again, that are somewhat new to the game, but need to understand this information as well. And the last part is around communication. And we've developed some visualization tools to help a broader group of people internally understand how to use the data to deliver better product, services, and solutions to customers and delivering on those goals that, again, I will propose are shared for all of agriculture. And so just in closing, again, I think it's a very important time for conservation, and I really hope that you all recognize that CTIC and OpTIS will hopefully play important roles in advancing the overall mission. I want to thank you all for attending, and I look forward to hearing from you now, I think, for the balance of the time, and understanding where you think OpTIS could be applied in other applications, ways we could improve it. One thing we've talked about is the potential for independent or third-party verification to make sure that we have good data integrity across different data sets, but models going forward, and then identifying ways for CTIC to help. And I'm certainly happy to talk with any of you offline from here today as a function of CTIC or John Deere. And with that, thanks for all those that organized the call today. And Dave, I'll turn it back to you.
Well, thanks very much, Mark. And we are going to get to the Q&A, definitely, as you just mentioned, John, or Mark rather. But we do have a brief interlude here, giving folks a little bit more detail about the new data visualization tool that we've recently introduced. And if Val, you could go to that next slide. I'd like to introduce briefly John Hansen, who helped develop this tool. And John, I don't know if you're unmuted and can say hi briefly to the group or not.
Yeah, I'm here, Dave. Yes, John Hansen. I work closely with Dave and Mike Comp to understand this data, to work with it, and to come up with a plan for how to present it in a way that makes sense to the industry. We think we're on a good track, but I hope you guys all here on the call get a chance to experiment with the tool, maybe take the survey and give us feedback so that we can continue to improve the effectiveness of it.
Yeah, and
so thank you. I'll turn it back to you, Dave.
Yeah, John, you did a great job. And I'm now going to also turn to another team member, Eugene Jakobsen, who helped develop a tutorial video which he'll introduce in a moment, just to show folks the power of the new tool that John developed. So with that, I'll hand it over to Eugene.
Hello, everyone. My name is Eugene Jakobsen. I am a GIS analyst at the Nature Conservancy. And as Dave said, I've created a brief demonstration video that takes you through the features of the OpTIS visualization tool and how to use it. So you'll be able to get a more concrete idea of what the OpTIS data looks like and how you can explore it. And you'll also see that the app provides a way to actually download the data as well. So we'll go ahead and play that for you now.
you through a visualization tool. This video will walk you through a visualization tool designed to let you explore CTIC's OpTIS dataset in a flexible and interactive way. The new CTIC OpTIS webpage allows you to interact with two different measurements from the OpTIS dataset: acreage and conservation tillage, and acreage and cover crop practices. On the left-hand panel, the web tool presents the 4 buckets of tillage information in the OpTIS data: conventional tillage, reduced tillage, in which 15 to 30% of the field surface is covered with crop residue after planting; reduced tillage high residue, in which 30 to 50% of the field surface is covered with crop residue; and no-till, in which 50% or more of the field is covered. It's important to understand here that the map illustrates the sum of reduced tillage high residue plus no-till, which is collectively called conservation tillage, divided by the total number of cropland acres in each spatial unit and averaged across years. Meanwhile, the trend chart below the map illustrates the percent adoption for each one of the 4 tillage methods. On the right-hand panel, the web tool presents acreage and cover crops, perennials, and winter commodity crops. Here, the map illustrates only the cover crop data, showing acres and cover crop divided by the total number of acres in the spatial unit and averaged across years. Meanwhile, the trend chart below illustrates the percent adoption for all 3 of the cover crop types in OpTIS. Both the tillage and cover crop data are available in both Crop Reporting District and HUC 8 watershed geographical delineations. You may switch between these geographic delineations at any time by using the CRD and HUC 8 buttons above the visualization. Please note that the tillage and cover crop dashboards are independent. Filtering or clicking on one will not affect the other in any way. Now we will focus on the visualization of conservation tillage by Crop Reporting District to demonstrate all the ways you can interact with the OpTIS data. The same behaviors hold true for the cover crop data and for when the visualization tool is in HUC 8 mode. To make things easier to see, we'll click on the full screen option on the Tableau ribbon. You can use the Escape key to return to your browser at any time, but we'll stay in full screen mode for the remainder of this demo. The top element of each visualization is the Year slider selector. This element allows you to select data between the lower bound and upper bound of the slider. The slider defaults to select the entire range of OpTIS data between the earliest year, 2005, and the most recent, 2018. You can see that the data in both the map and the trend chart changes as the slider is moved. If you'd like to reset the slider at any time, click on the Reset button in the Tableau ribbon at the bottom of the tool. The first way to interact with a map is to hover over any geographical area and observe the contents of the tooltip. Hovering your cursor over an area will display detailed information about the conservation tillage or cover crop data for that area. The second way to interact with a map is to click on a region. When you click on a region, you'll notice that the color of the rest of the regions will fade, and the data in the trend chart will be filtered to display only the data for the selected region. It is possible to select data for multiple regions at once. You may hold the Control button while clicking on multiple regions, or you may use the rectangle, radial, or lasso area selector tools. Clicking anywhere on the map outside the data area will clear your selections, or you may click on the Reset button on the Tableau ribbon as before. Hovering over the trend chart area will show you the percent of row crop acres using a given tillage method. Clicking on the trend area will highlight the selected tillage method, but will not affect the map area. Finally, this tool allows you to download the OpTIS data in several formats. If you find a view that you like, you may download it as a static image, PDF, or PowerPoint. If you first click on either the map or the trend chart, you may also download the raw data using the Data or Crosstab options, which will both allow you to download a CSV file that you can manipulate in Excel. You will have the option to grab either the full dataset or just the data for the map units you've selected. You may also download the data in Tableau workbook format. If you install the Tableau Public or Tableau Desktop software on your computer, you may interact with and even edit the visualizations. Thank you for your interest in the OpTIS data, and we welcome you to visit the URL on screen and try out the tool for yourself.
Thanks very much for your work on that video, Eugene. It was great. And again, thanks to John for the fantastic work on the tool. And for everyone on the call, if you haven't checked it out yet, I really do strongly encourage you to do so. So with that, I'm going to pass it back to, I believe, Val, right, Val?
Yeah, actually, we're going to have Shamitha facilitate questions. Again, if you hover at the bottom of your screen, there's a Q&A.
Yeah,
there's a Q&A button, and you can type your questions in there.
Thanks, Val. I believe we have Christine and Steve Worklow who are actually monitoring the chat and who will be facilitating the Q&A.
Yeah, it's great to see all this interest and a lot of great questions. I'm going to aggregate for the first one. There's a lot of interest in kind of the process of how to tell how the system tells the difference between, say, wheat or alfalfa and cover crops, or weeds and cover crops. And related to that, and I'm going to direct this one to Steve Hagan, related to that, is there also a differentiation between winter cover that's harvested for grain or harvested for straw versus winter cover that's simply a cover crop?
Thanks, Steve. Yeah, lots of great questions there. I'll try to tackle them, and Steve, you can follow up if I miss any of them. So that first question on discrimination between winter cover crops and perennials or winter commodity crops. I think Eugene's video touched on this briefly, but so we do separate those three, and we rely on a blend of cropland data layer information, as well as our own algorithms that I gave you a little bit of sense of during my part of the presentation, where we're looking at the temporal pattern of greenness. And just for example, when we're splitting out winter cover crops from winter commodity crops, we're looking for that winter wheat signal to carry a little bit further into the summer, whereas the winter cover crops end abruptly at spring planting. So we do split those out. And I guess the next one was on weeds, and I think it's a fantastic question, and I do think it's probably the thing that when we talk about 85% accuracy plus, the real challenge is that other 15% or so is most often related to two things. One of those is weeds. Intense volunteer crops or weeds can fool us, and we've seen that in some of the field observations and our comparisons there. And the inverse of that can also occasionally cause us problems. If a cover crop is planted but doesn't establish a vigorous or robust canopy, sometimes one of our data collectors will mark that as a cover crop, but we'll miss that on the remote sensing side. So those are great questions, and it's certainly where we continue to try to improve the separation of those. Did I miss another question there, Steve?
No, I think you did a nice job of capturing that. Thank you very much, and don't go far because we'll have more for you. But I'm going to switch this one over to Dave. There are a couple of questions about plans to expand OpTIS, whether it's to the southeastern U.S. or outside the United States. Can you talk a little bit about the future plans for OpTIS?
Well, I would probably invite TNC to comment more after I've finished, but certainly it is true that there are many other areas in the United States where row crops are grown to a large extent, especially, say, the Chesapeake Bay, the Southeast, the Delta region, and even out west, there's many regions where OpTIS data would be highly relevant. So we are pursuing that collectively, and I think there has been some recent success, for instance, in continuing the efforts in the I-states from 2019 and moving forward, as well as I think an indication that we might have funding coming to us as I recall, potentially from USDA, but someone needs from Dagan needs to confirm that before I talk out of turn. But my understanding is that there is, in fact, support for continuing in other parts of the U.S. I'm not aware of any efforts outside the U.S., but obviously the technology is directly applicable there. But again, the folks at Dagan or TNC may have more comments on that. I don't know, Steve or Bill at Dagan want to talk about the other parts of the U.S. part of that question?
Sure. Thanks, Dave. I mean, that's right. So we're updating the I states up through 2019 and 2020 as a team, and we're moving out spatially as well. I don't have the list in front of me of the exact states at this point, but it's safe to say that we're working to rapidly expand both in space and in time, aiming to get to contiguous United States within the next 12 to 18 months, and looking back through time. We also have done a little bit of work in Canada and with some partners, as well as starting to look at South America, and that's from the OpTIS remote sensing side. DNDC as a tool, as I mentioned, use of that goes back to the 1990s and has been successfully calibrated and applied across the world.
Great, thank you. So Steve, here's one for you, and this one is basically how do you handle error propagation through the various models?
Yeah, I saw that question. It's a great one. So in the data set that's available now, we've done a pretty simplified handling of error. So there are occasions when we don't have enough, this is from the remote sensing side, there are occasions when we don't have enough well-timed, clear satellite observations, especially as we look back in the time series before the launch of Sentinel-2, where we don't have enough information taken at the right time to provide an estimate with confidence. And so each pixel for which we make an estimate, we attach a level of confidence. And in this application, we chose a threshold. And information for which we have sufficient imagery, sufficient well-timed imagery, imagery providing a consistent pattern, if it's above this threshold that we've quantified, we provide an estimate. If it's lower than that threshold, we set those data aside and we produce an estimate. When we sum up to the watershed scale, we produce an estimate that only takes into consideration the area for which we had clear observations. And we assume, when we scale up acreage-wise, we assume that those same ratios in the areas for which we had observations applies to the areas for which we don't. And we send along with that the fraction of area for which we had good observations. As we move into the future, our goals are to take the extensive and growing database of field observations and make direct area links between this information that I mentioned about consistency and number of observations, and turn that into uncertainty limits, error bounds on the areas, and hope to unveil that as we move forward with wider application.
Great. We have a question here. I'm going to start with you, and feel free to yield the floor if you want to get out of the spotlight. Well, questions here about the fineness of the scale, and related to that, we get into issues of farmer privacy. So, can OpTIS detect within a field an area that may have been no-tilled versus an area that may have had some tillage? And if we're working at that fine a scale, where do privacy issues come into play, and how does OpTIS address those?
So yes, from the technical perspective, OpTIS relies primarily on satellite observations at the sort of 30-foot to 90-foot scale. So certainly subfield scale, and original estimates are made on that scale. And that information is then aggregated up to the farm field scale for processing within the soil biogeochemical model, and then aggregated up again to natural and political boundaries for distribution. So we're relying on publicly available satellite data at those resolutions to make the estimates, using the modeling at the field scale, then aggregating, summarizing up for the political and natural boundaries, and making those data available. And so the idea of making, through this project, those data available at the aggregated scale is in line with the protection of grower privacy. I don't know if Dave or Shamitha want to add to that.
Just to emphasize that here at CTIC, we are very concerned about grower privacy, and I know this is a key issue for USDA as well. And certainly everything that we do moving forward at CTIC will always place the highest possible value on that. So there's absolutely no intention here at CTIC to be releasing data in a way that would violate that basically that premise. Grower privacy is at the top of our list.
And I would add that it's the same for TNC as well. We support sharing the data at the aggregated scales publicly so that everyone's able to access that data. But we are respectful of grower privacy in that field scale data will not be shared.
Okay, I know we're coming up towards the end of the program, and we will get back to any questions we didn't answer. We will make sure that one of the panelists responds by email. So as long as your name was associated with the question, we'll get an answer back to you. And perhaps we'll even be able to share those more widely as we share the video of this program on the TNC and CTIC websites. But one question that comes up is, why is reduced till classified as 15 to 30% cover? Most of the literature I've encountered considers 30% cover the cutoff. How did you determine your classifications? Let's throw that one at Dave.
Well, yeah, and we have a slide on that, but we're out of time here. But I'll just say that those definitions have been in use at CTIC for quite some time. And I know there are some other terminologies that are used by different parts of USDA. And so we try to thread the needle here to keep things as consistent as possible between the way we classify things at OpTIS to the way things have always been classified at CRM. But basically, conservation tillage is very specifically defined and has always been defined at CTIC as greater than 30% residue cover. So the term high residue hasn't been as consistent over time, but generally speaking, we felt that it made sense to include the 15 to 30% category as well. But for us, the big number here at CTIC is 30% for conservation tillage, and then the other trick here is defining how much residue is associated with no-till. I think it was glossed over just a little bit, but there's a different cutoff for corn versus other crops because corn generates a lot more residue. So anyhow, but it's a complicated topic, but we're doing our best, and I can follow up more in greater detail with folks who have very specific questions there, but it is a bit complicated. But the big thing for us is 30% residue equals conservation tillage. Great.
I'm going to ask one last question that's on a practical level, and then I'm going to turn it straight over to Val. So is it possible to download the vector layer that could be open in ArcGIS software in the website?
I don't know. John Hansen, do you know?
Hey, these I'm assuming you're talking about the custom georegions, the crop reporting district and the watershed. I worked with Mike Comp to get shape files for use in that. I think the shape files I used came with a variety of different GIS portable file formats. So you could follow up with Dave, Mike, and I and we can see about sharing those.
Yeah, they're just standard shapefiles, so there's nothing really proprietary about those.
Great, thanks. Again, we will address the rest of the questions. I'm going to hand it back to Valerie and our polling.
Thank you so much. Thank you all for attending this webinar. Thank you, CTIC. Thank you to Dagan. Thank you to my colleagues at TNC for all your work on this and for joining the call today. There is a survey up on your screen. Please do fill that out. And we will put a recording up on the website, CTIC and TNC's websites. And it seems like there's a fair amount of interest in getting answers to the questions sent out to the attendees. So we will see if we can come up with a report and get back to you all with that. So I hope that you all have a great day. And I think that unless any of the panelists have something to say to close us out, once you're finished with your survey, I think that's it for us.
Thank you, Val, for facilitating this whole webinar. Really appreciate it.
Thanks, everyone.
Yeah, huge thank you from me here at CTIC as well. It was great to have all of the input from those of you with interest with questions. We will definitely get back to you with answers. And just a huge thank you to my colleagues here for a great presentation. And I wish everyone a great weekend.
Thank you all.